నాన్న సైలెంట్
Good afternoon, all the students. Now we are going to the periodic table. Electronic configuration of a periodic table. Yes, configure the elements of the periodic tables, and what we have considered here, one second. Here, the period indicates the values of n for the outermost value shell. The period in a periodic table is associated with the next higher principal energy level n is equal to 1, n is equal to 2. The first period is contained n is equal to 1 only. Means what? Here, especially the electronic configuration, already we have discussed in the last class. Electronic configuration is a periodic property of our periodic table. Okay, you know very well. Which one is the periodic table? Periodic property. Electronic configuration is only the periodic property of our periodic table. You know very well all. Got it or not? Which one it is? Electronic configuration. Now today we are going to discuss about electronic configuration only. What is the electronic configuration? Okay, now you know very well already in your first lesson only. Yes, 1:2, 2:2, 2p6 like that we written na. Above principle, principle, Pauli exclusive principle, and based on the principle, electron is enter into which orbit. That all we are discussed in the first class, first unit only. Okay, now we are going to write the electronic configuration of a different number of elements. Okay, clear or not? Yes, and here based on electronic configuration, how we divided the periods and as well as the groups. That is now we are going to discuss. Okay, yes, and now electronic configurations in period. Electronic configuration in a period. The period indicates the value of n for the outermost or valence shell. In other words, successive period in a periodic table associated with the filling of the next higher energy level. Yes, suppose you take a first period. We write the first period elements are contained the one. The lowest level is the 1s. Therefore, has the two elements hydrogen and as well as the helium. Okay, clear or not? The electronic configuration for our first period is the what? Or for our first period, we written it is as what activity. For our first period, it is taken as 1s1 2 1s2. Okay, clear or not? There is only in the first period how many elements are there? Number of elements are present in a yes, this particular thing it will become what? 2 only. Okay, first period. When you come for a second period, okay, now yes, in the second period there is a it will be start from okay now where it will be start from 1s2. There is a start lithium and third electron enter into the 2s orbital. The next element, beryllium, has a 4 electron and has the electronic configuration 1:2:2. Yes, the second period starts with the next element, boron. Like that, there is a, it will be end with the what? Actually, second orbit totally ended, and now there is a, it starts from where 2s1 2, okay, 2s2 2p6 means what? How many elements? 8 elements are there. Once check it, electronic configuration is observed here. The second orbit is the contained inside it. Yes, and as well as the first orbit. Totally, when you take a lithium, what is electronic configuration? 1s2, 2s1. Means what? In a period, it will be start from first orbit, second orbit, yes, third orbit. When you are entering into third orbit, that a period is a become third period. When you enter it is in a fourth orbit, that period is a become fourth. Okay, clear or not? Like that, we started the elements totally, the properties and as well as the arrangement of element is we are taken based on a electronic configuration only. Okay, clear or not? Yes, it will be started with 2s1 and ended with the what? 2s2 2p6. That is the second orbit. And third period. Okay, now what is the third period? What is the third period? Is the says for us? What is the third period? Is the says for us? Yeah, n is equal to 3 we are considered, and it's a start with the 3s1. Okay, already we completed up to that first, second also 3s1. It is ended with the what? A 3D. Okay, clear or not? In the third orbit, how many orbitals are present in that? Yes. How many orbitals? Yes, P and as well as the D also. Okay, now that is why there is, it is ended with the, yes, a sodium. It is started with the sodium and as well as ended with the argon. Okay, clear or not? And the fourth period starts with the potassium, added electron fill up with the 4s orbital and 3d orbital also coming in this one only. Yes, and the scandium is the Z is equal to 1. Okay, now Z is equal to 30. That is the field in the totally all together in a fourth orbit. It is a contain 18 elements. How many elements are there in a fourth period? It is a contain how many elements? 18. The third period how many? 8 only. And the fourth period it will be contain what? Totally 18 elements. It starts from 4s1. In the 4s1, 3D is also negative. Okay, clear or not? Yes, 4s1, 3D, 10. Up to that it will be available. Next, there is the fifth period. It will be started n is equal to 1. The 4D is the transition in series. Okay, in this one, 3D is the transition. Okay, it's a transit with the fourth orbit only. Okay, now the 3D orbit is also contained accumulated with the fourth orbit only. Electron not only contained in a fourth orbit. When there is a third orbit is a field, afterwards only electron coming into the fourth orbit. But it is in a, not like that. It is after once fourth orbit is filled with a partially and then 3D orbital will filled. Why it is, you know very well. Electron first selected which orbit? Low energy orbit. You know very well. 4s orbital is the low energy, then the 3D. That's why the 3D is called transition, which are contain elements. The 3D is as the electronic configuration. That elements are called transition elements. Okay, now yes, understood or not? N is equal to what here? 4. But there is a third orbit also contained in this period. That's why that elements are called according to the periodic table transition elements. Got it? And next one is the fifth period. It is also there. Okay, now fifth period n is equal to where the 5 is started. That is called the fifth period. But in the fifth period again will be contain 4D elements also. Okay, clear or not? 4F elements also available. Okay, that is why that is also contain transition element. In a sixth period, nothing but the n is equal to 6 where it will be started. That is only starting element of sixth period. N is equal to 7 where it is the 7. That is only called the seventh period. Okay, clear or not? Yes, totally where the n is started. N is the what? Principal quantum number, you know very well. That is indicate what? Orbital number. The orbital number n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, n is equal to 6, n is equal to 7. It's ended. Sir, n is equal to 8 is not there? Yeah, not there now. If you are become a scientist, you are find any elements, At that time, you are added that element to the periodic table. New periodic table make it. Got it or not? N is equal to 8. Till now, there is a no element have the electron configuration. 8 S1 not there. Okay, clear or not? Yes, whatever this 117 elements are there, it is enough to arrange in this particular thing. Got it or not? At that time, there is in case any elements are more, make it is become 8th period. Okay, clear or not? No 8th period now. There is only groups are contain 18. 7 periods are only there. 7th period is totally it's content somewhat black still. Okay, the 7th period is not totally filled. It is a content somewhat black. Okay, clear or not? Yes, suppose n is equal to 5 we are taken. That is a what? Start with the rubidium. Okay, na? Yes, and it's a contain of 40 transition elements and deuterium that is equal to 39 with a cadmium that is equal to 48. This period is ends xenon with the filling of a 5p orbital. Okay, clear or not? All the elements, one second, it's a start with the what? NS1. It is end with the what? NS2, NP6. Okay, all the elements are start with the what? Periods are start with the what? NS1. End with the what? NS2, NP6. Okay, now got it or not? 1 second, first orbit, start with the what? 1s1. First period, sorry. It is start with the 1s1, end with the 1s2. No P is available now. 1p is not possible. It's a start with the what? 2s1, second period. End with the 2s2, 2p6. Third one, 3s1. End with the 3s2, 3p6. Fourth one, 4s1, 4s2, 4s1. It is started. End with the what? 4s2, 4p6. Like that, it will be ended. Okay, the end thing is the period in a what? Inert gas. Okay, clear or not? The end period is a what? Inert gas. Okay, first period is a contain helium. Second period is a contain neon. Third period is a contain argon. Fourth period is a contain krypton. Fifth period is a contain xenon. Sixth period is a contain radon. Seventh period not contain any inert gas till now. Okay, clear or not? This is only about the periods and electronic configuration. By using the electronic configuration, easily we are searching for one particular element is belonging to which period and which group. Easily it is possible. Why? Because you know very well starting element and ending element period whatever electronic configuration. Meanwhile, between that whatever the electronic configurations are there, they belonging to that group only. Got it or not? Yes, I hope you got it here. Suppose 6th period is there, starting with the 6s1, ending with the 6s2, 6p6. Okay, clear or not? That is radon. The nature of the 6s2, 6p6, what is contained? Radon. Understood all of you? In this way, there is we consider about our periods. I hope you got it here. The periods are properties are contained as electronic configuration. Physical and chemical properties are as periodic functions of electronic configuration of a one particular atom. Got it? This is only about our periodic table. Yes, and moreover, there is below the 5f and 4f inner transition elements are there. They contain as the name of lanthanides and as well as the actinides also. Okay, we have it. Okay, that component. Only the thing is we concentrate on this one. Okay, now n is equal to whatever value is there. That is only that particular constant period. Okay, now n last valency is the contain what the n value. That is only become that period. Okay, now yes, suppose we are taken a chlorine. What is electronic configuration of chlorine? 1s2, 2s2, 2p6, 3s2, 3p5. The last valency thing is what? 3. That's why it is a belongings to which period? Third period. Understood or not? Yes, suppose you take a calcium. What is the calcium configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. That's why it is belonging to which period? Fourth period. The last one, last term in electronic configuration belongings to which n value? That is only become the period of that particular element. This is the about electronic configuration. Yes, you read it. The first element in the period and the last element in the period you have to should know. No problem. Last element compulsory inert gas only. Okay, clear or not? Yes, the rhyming is there in inert gases. Helium, neon, yes, helium, neon, argon, krypton, xenon, radon. Okay, the last element should be these things only. Okay, first period helium is the last element. Second period neon is the last element. Third period argon is the last element. Fourth period krypton is the last element. Fifth period xenon is the last element. Sixth period last element name is what? Radon. Okay, xenon and as well as radon. These are called inert gases. You have to should know names of inert gases, and as well as the first elements of every period name is also compulsory for you. And as well as there is a what is that? Already yesterday we are discussed it here. There is whatever our once first element and last element names are very important for you. Okay, now once check it here. Yeah, once check it. There is a first element of the first period is a what? Hydrogen. Last element is a helium. Okay, now first element of okay, now first element is a second period is a lithium. Last element is neon. Okay, now and 11th element is a okay, now sodium. That is the third period. The third period is a contain as a what? Yes, what it is. That is only third period. First element is the sodium. Last element is the argon. And next fourth element, fourth period, first element is a potassium. Okay, clear or not? Yes, it is a what? A potassium. The last element is a krypton. Okay, clear or not? First element is a fourth period is a rubidium, and the last element is a xenon. Okay, clear or not? And the fifth element is the fifth period is a what? A sixth period is a cesium, and as well as the last one is okay. Fifth period is a rubidium. First element. The last element is a xenon. Sixth period is a cesium. The last one is a yes radon. Okay. And seventh one francium it is. Okay. And the last element is a blank that we not have the name particular. Okay, clear or not? This is only about the first element and the last element. You have to know first group elements names, last group elements name. You get it. Okay, first group elements names what? Hydrogen, helium, lithium. Okay, lithium, potassium, rubidium, cesium, francium. This is the first group. What is the last group? Yes, helium, neon, krypton, xenon, radon. Okay, these are the things. Okay, you have to shoot compulsory. Yes, by heart these things. Why? Because these elements names are there. Okay, clear or not all the students? And here the electronic configuration also I am already given. Start with the NS1, end with the NS2, NP6. What is the N? In case the first period, the N is a 1. Second period, N is a 2. Third period, N is a 3. Fourth period is a N is 4. This is a very important. Got it or not? Yeah. Once again, please note down these are the things. First period, general configurations, and as well as the first element and last element. Okay, you have to write it. Yes, whatever the given in this our textbook, the summary you have to write for it. N is equal to 4. What is that? N is equal to 1, 2, 3. Fourth period. N is equal to 4. Fifth period. N is equal to 5. Yes, and as well as sixth period. N is equal to 6. Seventh period, N is equal to 7. Got it or? And as well as there is the electron configuration, electronic configuration, electronic configure. It will be taken as a one. What it is? 1s1, 2, last 1s2 only. And here 2s1, 2. Okay, yes, 2s2, 2p6. 3s1, 2. 3s2, 3p6, and 4s1, 2, 4s2, 4p6, 5s1, 2, 5s2, 5p6, 6s1, 2, 6s2, 6p6. Yes, till now we are started at 7s1, but ending till now we are not having. Yes, we ending element till now we not find. Okay, this is only about the electronic configuration. First element and as well as the last element. First element and as well as the last element names. And write in symbol only. You have to write clear name. You have it in your periodic table, the names. Okay, the first element is our hydrogen to helium. Okay, now and as well as here lithium to, yes, what it is? Neon. Lithium to neon. Here, what it is? Sodium to argon. Sodium to argon. And next, what we are considering here? Fourth one. Yes, there is potassium to. Okay, na? Yes, krypton. Clear or not? Fifth one is the what? Rubidium to xenon. What xenon means? Xe. Okay, sixth one is the what? Sixth one. Yes, francium. Yes, cesium. CS. Okay, clear or not? Two, where radon, orange. Orange. Yes, francium to somewhat. We don't know till. Okay, about that name. Yeah, this table is indicate maximum information of a periodic table. Okay, now what is the first period? What is the second period? What is the n class group? What is the okay now? Yes, configuration, electronic configurations. Okay, now when you know the first and last, meanwhile you have to write. You know very well write to that by using Miller diagram. Already we are discussing. When you know the first element and last element, okay, now meanwhile the electronic configuration of all the elements are possible to write by Miller diagram. Okay, when you know the Miller diagram, you know it. When you know the atomic number also. Atomic number you have to know, and as well as Miller diagram you have to know. This one you have to know. About 117 elements you get. Okay, now this is a very tough task and great task. Try it level best. Okay, clear or not? Write the electronic configuration of all elements. Okay, now yes, and practice it. You may get. Okay, clear or not? I hope you got it. It is. This is only the information about our periodic table. Next. Now, all the concerned teacher, please take one screenshot of our whatever our periodic table. Okay. Yes, it will be utilized for you. Okay. Now, please take a screenshot for the students' purpose and send to the groups. It's useful for the students. Please take a screenshot and send to that. Otherwise, you download the periodic table of one picture and send to that particular 8th class groups. It will be useful for them. Yeah. This is only about the concepts of our electronic configuration based on the yes, what is the changes are coming in our periods and all the groups. Okay, the next component is based on the filling of the electron in orbitals. We classified our elements are into four yes, the classifications. Okay, now we have the four orbitals. What is that four orbitals? S orbital, P orbital, D orbital, F orbital. Okay, now we divide our total periodic table into different blocks. Okay, it is dividing into different blocks. That is only called as the blocks of okay, now blocks. This is dividing into different blocks. Okay, now S block element and as well as the P block, Okay, clear or not? And as well as the D black and as well as the F black. Like that, there is we divided our all elements into the what different class. Black S, P, D, and as well as the F. Okay, clear or not? It will be block. It will be one more block. Like that, we are consider the different blacks here. It is a called S black element. It is a called a B black element. It is a called D black element. It is a called a F black element. Okay, clear or not? Which one is a called S black element? Which one is a called a P black element? Which one is a called D black element? Which one is a called a F black element? Which one is a called S black element? Yes, which one is a called S black element here? There is electrons are which are contain outermost electrons whatever they that contain in S black. Okay, clear or not? Which one? S orbital. That is a called what? S black elements. Got it or not? That whatever outermost electrons are contained in a S orbital, that is only called what? S black elements. Suppose you take here our hydrogen, the electron it is a contain 1s1 only. Helium, it is a contain electrons of what? S orbital only. Suppose you take a lithium, it is a contain electrons in a where? Yes, 1s2, 2s1. It is also S black only. And as well as there is a why because outermost orbital contained where? S only. And now we take a beryllium. It is a contain 1s2, 2s2. It is also outermost contained where? S black on S orbital only. It is S black. Now the boron. Once come to the boron, 1s2, 2s2, 2p1. No, it is not a contain only S orbital. That's why it is not a called a okay na S black element. It is a called a what a P black element. Okay, clear or not? Yes, the S black is nothing but it should be contain the electrons in a outermost electrons only, not all electrons. In this one also electrons are contained in S orbital, but it is not considered as a S black elements. Okay, why these things are we are considered? All the S black elements are contain some same properties. Okay, for analyzing of a chemical properties, for analyzing of a physical properties, it is a difficult thing. Why? Because lakhs of okay, the compounds are formed because of this 117 element combination. One element is combined with another element. Lakhs of combinations are get. Okay, clear or not? Yes, I hope you got it here. We have only one substance in the world. No. Yes, this chalkpiece is one of the substance. Duster is another substance. Yes, this whatever the book is another substance. It is a combination of so many elements. Okay, now yes, and our human body is made by the 52 elements. In that one, blood is made by the ferrous and as somewhat other elements. We want to check about the, we want to dealing about the properties of the substances. It's a very difficult process when we not make it commonized. For the commonizing the things purpose only the periodic table is utilized. Okay, clear or not? The behaves the same. The construction is the same. The behaves are the same or not? Okay, when you check it constructions, okay, we are arranged the particles in the same manner. The constructions looks are same or not? When you go for a villas, the villas are all looks are same. When you go for a Indirama colonies, there is a what actually the colony, whatever houses are there, same only. Double bedrooms are nothing but same only. Why? Because they contain construction same. Inside the atom also, the electrons are constructed in the same manner. They may contain same properties or not. Yeah, that is only the main property. For this purpose, we are dividing these elements into some groups, some periods, depending on some properties. Either may electronic configuration, or maybe valency based, or maybe non-metallic nature or metallic nature. Okay, or maybe there is a now whatever we are considered blacks. All S black elements are contain some common properties. All F black means what? The element, whatever outermost electrons are there, they contain in F black. F orbital, that is called F black element. If it is a contained in a D orbital, it is a called D black element. If it is a contained in a P black, it is a called P orbital, it is a called a P black elements. Got it? Here we consider the what? Our first group elements and as well as the second group elements. Most of the things are containing the what? S orbital. Suppose you take a sodium. You take sodium. Sodium is a which black? S black only. Magnesium, S black only. Got it or not? Yes, magnesium is S black or not? Aluminium, S black only. Why? Because what is the electronic configuration of aluminium? 1s2, 2s2, 2p6, 3s2. Okay. Yes. Sorry, aluminum is not S platinum. Yes, 3s2, 3p1. Got it or not? This is only about the electronic configurations of our elements. Okay. Yes. Thank you, students. Bye. Take care.